Students, this is from Uncovering Chemistry. Today, in video 21, we are going to discuss about group 18 elements. Now, when we know about group 18 elements, they are also called noble gases. Why? Because they are unreactive and they are all monoatomic in nature. Now, group 18 elements, when we write here, group 18 elements, I think everyone know that. No? Group 18 elements are what we say it is helium. Now helium is the only one which is having 1s2 configuration, other all will have ns2 np6 electronic configuration. So when we say helium is there, then neon, argon, then xenon, krypton, then xenon, radon and oganesson. What oganesson means its symbol is Og. Okay, this is the 118th element, what we call it as. Okay, so helium, this is neon, argon, krypton, xenon, these are the names, radon and oganesson. Clear? So this was being predicted, but now it is 119 elements which are known, what we say. So these are group 18 elements. This all what we have, they have the last shell, that is ns2 and np6. ns2, np6 completely filled, what we say. Okay. So this is the electronic configuration of what we call it as of organism. All what we call it as group 18 elements. Now, when we talk about this gases, all these gases are chemically, these are all gases. So you can write here, all these gases are chemically unreactive. Clear? Second thing, they are in monoatomic form. Clear? It is not like how we are seeing fluorine is Cl2, helium, neon, what we call argon. These all are in monoatomic form, not like this two will come there. Understood? Then, when we talk about its what we call it as, we'll start with the physical properties, what we have seen, atomic and physical properties. Atomic and physical properties. Okay? Now, when we talk about atomic and physical properties, you will see first electronic configuration. Because occurrence is not there in your course, what we say. Electronic configuration. Clear? We know noble gas configuration in the last shell, valence shell, there are what we call 8 electrons are there. Okay, so all noble gas, what is the word? All noble gas has electronic, you can see the electronic configuration ns2 np6 except helium. Helium is having 1s2, what we call it as there is no p orbital in helium, so it is 1s2 only, because the atomic number is z is equal to 2, what we say. So I think this part is clear for electronic configuration, what we say. And many of the properties of noble gas, including their inactive nature, are ascribed to their closed shell structure, because completely filled shells, what we say, that is the reason, what we say. Then the next is ionization enthalpy. I will drop this. Okay. The next one we are going to talk about is about ionization enthalpy. Clear? Now, when we talk about ionization enthalpy, So due to what you call it a stable electronic configuration. The word is what? Due to stable electronic configuration, the ionization enthalpy, these gases have very high ionization enthalpy. Understood? So this is the reason why these gases have very high ionization enthalpy. Ionization enthalpy decreases down the group due to an increase in size. Ionization enthalpy decrease down the group with increase in size. Okay, this is the reason regarding ionization enthalpy. Okay, now the next one what we are going to discuss in is about what you call it as atomic radius. Electronic configuration over, ionization enthalpy over. Now comes the atomic radius. Now atomic radius you can easily come to know. Down the group when we go, the atomic size increases, what we say. Right now, down the group when we go, the atomic size increases. Okay, so we can write down atomic radii increases down the group with increase in atomic number. Understood? So this was all about physical and chemical property. Electron beam enthalpy is not there. Now we will discuss about its chemical properties. What we will discuss about chemical property. Now in chemical property there are two things which are there in your syllabus, that is xenon fluorine compounds and xenon oxygen compounds, that we are going to discuss next. Okay, just a minute. Now first we will discuss, that is given on page number 210, xenon fluorine compounds. Xenon, because very less compounds are formed in this case, and that are xenon forms with the fluorine, xenon fluorine compounds. Okay. When we talk about this xenon fluorine compounds, okay, when we talk about xenon fluoride compounds, xenon and fluorine forms three compounds. Clear? Now, when we talk about these three compounds, they are XeF2, XeF4 and XeF6. XeF4 and XeF6. Okay. Now we are going to discuss about the preparation of xenon fluoride compounds. Okay. Now in this preparation, the first one, when we say the first one, that is XeF2. So it is very simple and easy. You can remember this. Xenon gas is taken in excess and with the fluorine it is heated at 673 Kelvin and 1 bar pressure. Okay, so what you will get here in this XeF2. Now this is in solid state. This you don't forget, otherwise your marks will be deducted if you don't write this. Okay, so you have to be very careful if you want to score maximum marks. So See that you write this. Then another preparation of XeF4, that is xenon again, that gas, no need to take excess, 2F4. Fluorine is taken in excess because if you see fluorine 2 and here fluorine is 4. Okay, so when you take this Xe plus 2F2 in presence of 873 Kelvin and 8 bar pressure. Now this is the highest pressure what you say. What you will get XeF5 as a solid. Now in this you have to remember that XeF2 is in ratio 1:5. Xe and F2 is in ratio 1:5, means 1 part xenon and 5 parts what we call it as fluorine must be there. Understood? Then the third preparation. Now Xe again plus F2, 3F2 in presence of what we call temperature is 573. If you see temperature here increase, but now it is decreasing because pressure is highest here, 60 to 70 bar pressure, highest pressure what is being taken. You will get what? XeF6. Now in this case Xe and F2 are in ratio. Xe and F2 is or is not R, we can write R because 2 are there. R in ratio 1:20. Understood? So this is the part what you have to remember. Okay. Now this was xenon XeF6 can also be prepared from and also there is another technique also to prepare this XeF6 that is XeF4. I will take this one where it is here F4 will come sorry. Okay, so XeF4 1:5 means understood this part. So XeF4 is treated, this XeF4 is treated with O2F2, okay, in presence of temperature 143 Kelvin. What you will get? XeF6 plus O2 you will get. Okay, so this is also the preparation technique what you can see here, okay, for xenon fluorine compounds. Now we'll talk about the physical properties of xenon fluorine compound. Physical properties of xenon fluorine compounds. Okay. Now these all are the questions being asked separately. So be careful when you write. Now when we talk about the first physical properties, what we say, XeF6 are all F2, XeF4 and XeF6. What we say? These all three are colorless crystalline solid. What are they? Are colorless crystalline solid, which sublimes what we call, which colorless crystalline solids and sublime readily at 298 Kelvin. Okay, then the next property when we say, this all are given in textbook but I am writing in form of points so you can write down, it will be easy for you to understand. They are powerful fluorinating agent. Powerful fluorinating. Yeah, fluorinating agent. Now this we have already seen in our previous topics what we say of group 17 elements when we discuss about fluorine. Okay, so they are powerful fluorinating agent and undergoes ready hydrolysis with even a trace of water. Trace means only little water is there, no? If a trace of water, if hydrolysis, what you call, even with a trace of water. Now for that it is given HCF2 is hydrolyzed as follows. Clear? So one equation we will write here, so it will be easy for you to understand. 2HCF2 plus 2H2O gives you 2Hc plus 4HF plus O2. Okay? So this is the property, fluorinating agent. Then HCF2 can donate fluorine to HCF2 can donate fluorine to fluorine pentafluoride, PF5 what we say. Understood? As follows. Clear? Now when we write this, you can write down this what we call equation, reaction equation. PF5 gives you this is a complex which is from HCF. Now this one, regarding this complex we will study in 9th chapter, coordination of complex compound, what we say. HCF plus into what we call it as negative what, PF6 minus. Okay, this is the complex which is formed by donating fluorine, what we say. Then the fourth number point. Now when we talk about this fourth point, in the same way HCF4 can donate in the same way. HCF4 can donate fluorine. HCF4 can donate fluorine to SBF5, antimony chloride, pentafluoride, as follows. Okay. Now in this when we write here, you can see HCF4 plus SBF5 gives you what? XEF. XCF3, sorry, CF4 is there, no? So XCF3, this you can remember like this. Here 2 is there, 1 it is donated here, and here 4 is there, 1 is donated, so 3, SBF6. These are the complex which are formed, you can remember like this. Then the next one, what we say, just write it at the bottom so that no need to rub this. Fifth one, alkali metals, however, alkali metal fluorides. Clear? When we say alkali metal fluorides like NaF, KF, etc., can donate fluorine, as follows. This part I think you understood how it can donate fluorine. So this was all about what we call it as physical properties of a xenon fluorine compound. Now we will talk about the structures, what we see. Okay. Now we will talk about the structures of xenon fluorine compounds. Okay. Now, when we talk about the structures of xenon fluorine compounds, you can easily see First one, that is xenon XeF2. I am talking about what? XeF2. These are the lone pair which are there on xenon. Okay. Now this structure, what we say, is a linear. Linear means 180 degree. This you can say linear. Next one, when we say XeF4. XeF4. Now XeF4 is square planar. You can see from the structure only. Now when we talk about the square planar, Xe, here F, and here F. Okay. Now this XeF4 square planar structure and one electron pair like this. Okay. Then XeF6, what we call. XeF6, when we say it is distorted. XeF4, another one structure is also there. That I will draw below this only. Now XeF3, F6 have a distorted octahedral. Distorted octahedral structure. Clear? Now that is, we draw here. Octahedral means 8 corners. If you take, it will be better. 6. Okay. And here one electron pair on xenon. X3 will come. Okay. This is the structure what we say. Then the next one, structure of XeF6 square pyramidal. XeF4, sorry. Square XeOF4 it is. In your textbook, I think you will not do that, so we will not do that. Okay, so this was all about what we call it as the structure, what we say, of xenon fluorine compound. Now we will discuss about the another compound which is formed by fluorine, that is xenon oxygen compound. Sorry, fluorine, not xenon. Xenon oxygen compound, that we are going to discuss. Okay, just a minute. Okay, we will do one thing. This video is already of 23 minutes, so xenon oxygen we will do it in the next video. Okay, next video will do. Till then, write down this all the topics which are given with the structures and all. It will be easy for you to learn for your exam. In the next video, we will be discussing about xenon oxygen. Okay, thank you.